All right, let's talk about multiplying rational expressions. This is going to be the first of, I think, 2 videos. So multiplying rational expressions. We're going to find the product. Also, we're going to state any restrictions. So just like when we multiply basic fractions, like if I told you, all right, let's take 2/3 times 1/4. What you would do there is you would multiply the tops, say 2 times 1 is 2, and multiply the bottoms, 3 times 4, which is 12. And after you multiply, you simplify. So just like how I had that simplifying rational expressions video, same thing. So we're going to take 2 divided by 12, which is 1/6. So kind of works the exact same way. So we're going to do one step, and then all of a sudden we're back to types of problems we've done before. So I have this set up here for my rational expressions that we're multiplying. So first thing I'm going to do is I'm going to multiply the top. So I'm going to start and kind of go through, I'm going to go through my integers, that's my numbers, then go through each variable. So I have a 4 times, well, over here would be like a 1, so I have 4, just have an x, y to the 3rd times a y becomes y to the 4th. On bottom, just have an 8, x squared times x is x cubed, and a y. So there's my setup, and now we're back to problems that hopefully at this point we know how to do. One thing I'm going to do is I'm going to look at, is there any factoring that can go on here? Currently there is none. So after that I'm going to go to restrictions. And remember, restrictions, we're talking about we do not want our denominator equal to 0. So we're focusing on the variables, seeing if we can find ways to make our denominator 0, because that's what we want to avoid. So I have 3 pieces here, 3 factors multiplied here. 8 is a factor, x to the cube is a factor, y is a factor. So what you're really doing to check for restrictions, you take each factor and solving by second n equal to 0. So we have 8 equals 0, that's not going to do anything. X cubed is equal to 0. If you solve that, all you would do is take the cubed root of both sides, and you find, well, x equals 0. So one thing we want to avoid is we do not want x equal to 0. If we plugged in a 0 for x, we're going to get 0 in our denominator, which we do not want. The last piece there, set y equal to 0 and solve. Well, you figure out, well, y cannot be 0 then. So my restrictions are x cannot be 0 and y cannot be 0. So after that, after you have restrictions, we can actually do this simplifying part. So what I'm going to do is I kind of take it piece by piece. I start with my numbers, then I'm going to go through each of my variables. So I'm going to start with numbers, then go to my x's, then to my y's. So let's start with my numbers. I have 4 over 8. So that's 4 over 8. That reduces to 1/2. And I'm writing a big fraction here because I know I'm going to have to deal with x and y. So 1/2. 4 over 8 reduces to 1/2. Next I have an x divided by an x to the 3rd. So I have 1x on top and 3 on bottom. 1x on top, because that's like x to the 1st. 3x's on bottom. Well, if I take away 1 from the top and 1 from the bottom, I have no x's left on top. And my x to the 3rd on bottom becomes an x squared. So instead of having 3 there, I now have 2. And then I move to my y. I have y to the 4th divided by y. I have 4 y's on top, and then just a single y on bottom. So if I take a y away from both, then I have 3 left on top, so that would be y to the 3rd. So multiplying these 2 rational expressions, you're going to get an answer of 1 y cubed divided by 2x squared, with restrictions of x cannot be 0 and y cannot be 0. Alright, second one. So I have 2 new rational expressions here. I just want to show you one more example. First thing I'm going to do again is let's multiply this together. So I kind of go through it step by step. Focus on my numbers, then my x's, then my y's. So starting up top, I have a 48. Well, nothing else there, so I'm going to have 48. X to the 5th and an x squared is going to be x to the 7th. Y cubed and y is y to the 4th. And then on bottom, I got a 6 an x cubed, and a y to the 6th. So after I combine it together, I now have just a single rational expression, so I need to simplify that. So I'm going to focus on the bottom because remember, restrictions, we do not want my denominator equal to 0. So I have three factors there. I have a 6, I have an x to the cubed, and a y to the 6th. The 6 really isn't going to come into play. X cubed, if we solve that equal to 0, you're going to find, hey, x cannot be 0. Y to the 6th is equal to 0. Well, what would make this 0 equal 0? Well, y is equal to 0. So my restrictions are x cannot be 0, y cannot be 0. So at this point in time, you're going to find, well, the restrictions, not a whole lot of variation. The more problems we do, you'll see what changes the restrictions a little bit. So it will take some time, but we'll get there. So back to the problem, what I'm going to do is I'm going to focus on my integers, that's my numbers, then my x's, then my y's. So I'm going to start with 48 divided by 6. So that's like the fraction 48 over 6. If I took 48 divided by 6, what I'm going to get is I'm going to get 9. So I'm going to put that on top. Next I go to my x's. I have x to the 7th on top, x to the 3rd on bottom. So I have 7 x's on top, 3 on bottom. 7 up top, 3 on bottom. If I take away 3 from both, I'll be left with x to the 4th up top. None left on the bottom. And then finally I go to my y's. I have y to the 4th and y to the 6th. 4 y's on top, 6 on bottom. If I take away 4 from top and 4 from the bottom, I'm left with 2 left on the bottom, so a y squared on bottom. So my answer is 9x to the 4th divided by y squared with restrictions of x cannot be 0 and y cannot be 0. And that was multiplying rational expressions 1.